Hey everybody, it's Mr. Carr again. Today we're going to be starting off with Unit 8. Unit 5, but 8-1, multiplying and dividing rational expressions. Okay, so one of the skills we'll be using that we've done before is factoring polynomials. It's going to come up a lot in this unit. Okay, so today we're going to talk about simplifying rational expressions and not complex fractions. That'll actually be for a future lesson. But now we're just going to focus on rational expressions. Okay. So what we mean by a rational expression, it's in the name itself. It's a ratio. So a rational expression is anything written as a fraction. Oops. Okay. But they're going to be more complicated than the fractions you've dealt with before. So when we look at that, here's an example of this. Simplifying a rational expression right here, we have multiple factors. So when you look at this one here, we actually have, if I rewrite it, 3 times y times y plus 7. I have 3 factors in the numerator. In my denominator, we have y plus 7 as a factor, and I can actually factor out y squared minus 9. That's a difference of 2 squared, so I'm going to make it y plus 3 and y minus 3. Okay, so what we have is 3 things multiplied in the numerator and 3 things multiplied in the denominator. These are all my factors. With a rational expression like this, we are going to be able to look at when to simplify it, we want to be able to cancel out common factors that are in the numerator and in the denominator. So what that means is y plus 7 and y plus 7 match up. They cancel each other out. It's just like taking something divided by itself. From there, I'm going to double check, is there anything else? No, nothing else is in common. There'd have to be something like 3 and some other number in the denominator, or y and y, or y plus 3 over y plus 3. So to simplify this, I'm just going to go ahead and multiply those together as 3y, and my denominator, y plus 3, y minus 3. If you want to, you can just rewrite this back as y squared minus 9, but it's not necessary. Okay, so that's my simplified version right there. When we look at another thing that comes up with these irrational expressions, we want to make sure that there are times that our expression is going to be undefined. Okay, and what causes being undefined is if we ever divide by 0. So what makes a rational expression undefined? Forgot a letter there. Undefined and dividing by 0. Since we're dealing with fractions, anytime we have a 0 in the denominator, that is undefined. So it doesn't matter what's in the numerator, but if I ever have that right there, that is always going to be undefined. So in our scenario here, I'm going to rewrite it in its factored form. We have 3y, y plus 7, y plus 7, y minus 3, and y plus 3. Our focus is to create this right here. If it's undefined, it's based on these 3. So what creates our undefined is whenever the denominator equals 0. That's our concern. So that's what gives us our undefined ideas. So I can just take this y plus 7, y minus 3, and y plus 3 and set it equal to 0. So from here, we can apply the zero product property. If y plus 7, if like these multiply together to 0, the only way for this to be true is if y plus 7 equals 0, y minus 3 equals 0, and y plus 3 equals 0. So that means 3 restrictions. Y equals -7, y equals 3, and y equals -3. We'll talk more about the idea of the domain restriction, but that's what's creating that here. Okay. So again, these 3 numbers are limitations on this. They would cause the denominator to be 0. So that means that they are not part of like any numbers we can consider as in these expressions here. Okay. So let's get to the other part of today. That is simplifying it. Let's talk about the actual multiplying of our rational expressions. So the idea of multiplying out rational expressions is we just multiply the numerators and multiply the denominators. So if it looks like this right here, if I have a fraction a over b times c over d, that's the same as a times c over b times d. It's no different from multiplying fractions in the past. Okay, so as a quick example, if I took 2/3 multiplied by, let's go 9, Let's go 9/16. Okay. We, in the past, would have just done 2 times 9 and 3 times 16. But another thing we can do to help with this idea here, we can think about common factors, especially diagonally. If I look at 2 and 16, those are both divisible by 2. So if I divide by 2, that's a 1, divide by 2 is an 8. If I look at 3 and 9, those are both divisible by 3. So I divide by 3 is 1, divide by 3 is 3. Now look at my numerator, it's 1 times 3 is 3, and my denominator is 1 times 8 is 8. So that is an idea that I can apply here. When we look at this right here, we're going to multiply these rational expressions, but I'm going to look for those common factors to reduce it first. Because technically I could just put it all together. I could do 8 times 7. Like one option is to just multiply across the numerator. So 8 times 7 is 56. And then I have x times y squared. In my denominator, I'm going to have 21 times 16 is 336. And then x to the third, y to the third. That's an option. But I'm going to suggest a slightly different way, which is this. If I look at 8 and 16, both divisible by 8, so I get 1 and 2. Same thing with 7 and 21. Divide by 7 is 1, divide by 7 is 3. Let's do the same thing for my variables. Just like we've done in the past, if I have x in numerator and x to the third in the denominator, I can actually cancel out an x here, so that turns into a 1, but this will turn into x squared. Y squared and y to the third. So this will actually cancel that completely out, so that's a 1. And then this will just take away 2 y's, so it's just y to the first. So in my numerator, I have all 1s. So 1 in my numerator. In my denominator, I have 3 times 2, gives me 6. And then I have an x squared here and a y to the first here. And that's my way to multiply through and simplify this. Okay, so we're looking for those common factors to reduce it by, and also multiplying across the numerator and multiplying across the denominator. One more way I can kind of make it a little bit more tricky is if I do polynomials in my numerator and denominator. Okay, so from here, we're going to go ahead and do the factoring. So that's going to be a big part of this unit again. When in doubt, factor it out. So in this case, I got k minus 3 over k plus 1. 1 minus k squared, that is the difference of 2 squareds. So I'm going to do 1 minus k and 1 plus k. And then here I've got k squared minus 4k plus 3. So if I focus on my patterns, I know it has to be k and k. It's a positive and a negative here, so it's got to be 2 negatives inside, which means it's a -3 and a -1. Once again, we're looking for common factors. So that means k minus 3 and k minus 3 are common factors here. K plus 1 and 1 plus k are also common factors because I can say this, k plus 1 is the same as doing 1 plus k, okay? It's a commutative property. What I'm left with is 1 minus k over k minus 1. So with subtraction, it's not exactly the same, but I can do something a little bit different here. In my numerator, if we factor out a -1 from that, so I can take a -1 out of the 1 and the negative k. So if I do that, I'm going to end up with a positive k and a -1. Well, now I have common factors with k minus 1 and k minus 1. Those can cancel each other out, so I'm left with just a -1. Okay, and that's it for multiplying. So again, as a quick reminder, we are ultimately going to multiply across the numerators and multiply across the denominators, but it might be a good idea to first do any kind of factoring and then simplifying by canceling out common factors in the numerator and the denominator. And it can be common factors vertically like this, they're in the same fraction, or diagonally like this. Okay. All right. And that's it for today. Take care, everybody.